I'm going to show you a machine. Can you hear it? Don't you think there's something strange about this sound? It sounds very different from the mechanical sounds we're used to, but it still has a consistent tempo of its own. This isn't the sound of a broken machine. It's as if we're hearing the rhythm of a living mechanism with its own pulse right now. Many of the devices we encounter in our daily lives have a rhythm. The beats of a metronome, for example. Or the signals of an EKG device that measures the rhythm of our heart. Even the sound coming from a sewing machine has a certain tempo. All of these follow a regular rhythm, but we are the ones who design them, with mechanical setups, with batteries, and with certain software. And they repeat a certain rhythm in the way we design them. But here we have a completely different situation. A man-made object is not following the rules set by man. It's acting as if it has a will of its own. So, can a substance have a pulse of its own? I mean, is it possible to transform a substance into a state where its atoms keep their own rhythm? To understand this, we first need to look at nature's most orderly state, that is, crystals. Normally, atoms are generally distributed randomly, just like in glass. For example, it's the same in this glass. The atoms are randomly distributed. By the way, this is our little one's mirror. She's a 12-month-old girl. That's why its color is pink like this. Anyway, what were we saying? In most substances in nature, the arrangement of atoms is not regular. However, in the substance structure we call a crystal, the situation is different. In them, atoms are arranged according to a specific geometric rule. They don't just scatter randomly. We encounter them frequently in our daily lives. For example, that simple grain of salt on our table is actually made of perfect cubes. Or think of a snowflake drifting down from the sky. They also have regular hexagonal patterns. All these crystals have a common feature. Their patterns repeat continuously in space. Meaning, if we look at an atom inside the crystal and shift a little to the right, we see the same regularly arranged atoms. If we go up a bit, the same pattern continues there as well. At this point, scientists ask this question. Since nature can arrange matter so perfectly in the 3 dimensions of space, could it possibly establish the same order in the 4th dimension, that is, in time? Imagine a system that, instead of heating up and dissipating with external energy, uses that energy to create its own stable rhythm. Just like this device I showed at the beginning of the video. And that's how the idea of a time crystal was born. And for the first time, scientists announced that they had produced a time crystal visible to the naked eye. And that is exactly the reason why I prepared this video. I'll get into the details of this development, which made headlines as breaking news, in just a moment. But first, I want to take you back to the beginning of this idea. It all started with a question that occurred to Nobel laureate physicist Frank Wilczek. If crystals in nature organize matter perfectly in space, can they also organize it in time? In fact, this idea of Wilczek's was based on one of the most fundamental concepts in physics: symmetry breaking. The laws of physics love symmetry. That is, they expect an event to occur with equal probability in every direction. Imagine a pencil balanced perfectly on its tip. At that moment, the pencil is in a state of perfect symmetry. It could fall to the right or it could fall to the left. It has an infinite number of possible directions to follow, and they are all equally likely. But with the slightest disturbance, the pencil falls and is forced to choose just one of those infinite possibilities. In other words, a symmetry breaking occurs. What we call time normally flows in perfect symmetry, where every second is identical to the next. So could a substance, just like that falling pencil, break this time symmetry and choose its own unique periodic direction? Instead of using every second equally, could it set its own rule, saying, I will oscillate once every 2 seconds? In other words, can a stable, constantly repeating rhythm be created within matter? I know this sounds as impossible as a perpetual motion machine, because normally the laws of physics tell us this. If a system is left alone, it will settle into a state of rest. For example, if you push a swing and let it go, it will eventually stop. Nothing moves on its own without an input of energy. And something that moves with energy is also destined to stop one day. That's why it's impossible to create a machine that works forever, like a perpetual motion machine. Many scientists oppose the idea proposed by Frank Wilczek for this very reason. But then it became clear that what Wilczek meant wasn't a machine in perpetual motion. He was saying that quantum systems could establish a periodic order within themselves, because the quantum world has its own completely different set of rules. And by using these strange rules like a key, scientists unlocked the door to what was thought to be an insurmountable barrier in physics. In 2016, the first signs of the existence of a time crystal were observed in a laboratory setting. To do this, a research team from the University of Maryland built an extraordinary setup in a quantum laboratory. They suspended electrically charged atoms, or ions, in midair. To do this, they used a special electromagnetic trap. The atoms weren't touching each other, but thanks to quantum entanglement, they could sense each other's presence. Then they began to send laser light to these atoms at regular intervals. This light was flipping the magnetic orientations of the atoms, known as spin. Each laser pulse was like a beat of a rhythm for the system. It served as a signal for the atoms to flip their spins at the same time. But something unexpected happened. The atoms did not follow this given rhythm exactly. They responded at half the speed of the tempo given by the scientists. They created their own rhythms. And most importantly, they didn't heat up in the process. In other words, they didn't scatter and get dragged into chaos. They behaved with extreme stability. This was a time crystal behavior observed for the first time in history. Just like atoms form crystal patterns in space, like the examples we gave of snowflakes and salt. Here, matter began to form a regular pattern in time. Around the same time, another research group at Harvard University reached the same result using a completely different method. They searched for the rhythm of time in the heart of a diamond. There are microscopic defects inside diamonds. So in the flawless pattern made of millions of identical atoms, there can be very tiny differences at some points. So when the researchers applied rhythmic energy to those defects using a different method, they saw the same surprising result. Those small defects in the diamond also responded in unison, with their own slower rhythm. So how did they observe this rhythm? After all, the defects in the diamond are too small to be seen with the naked eye. They aimed a laser at these defects. The brightness of the emitted light varied depending on which direction those invisible quantum spins were pointing. The scientists also saw that the light reflected from these defects fluctuated at half the speed of the rhythm they provided. In other words, they observed the rhythm of the light. That's why all these initial discoveries were considered indirect. Yes, a time crystal was created, but no one could see it directly. The main question on their minds was this: could this strange state of matter also exist in larger and more complex systems, that is, systems closer to the real world? The answer to this question came in 2021. Researchers using Google's quantum processor named Sycamore managed to create a time crystal that was much larger and more stable than previous ones. More importantly, this new state of matter was able to maintain its internal rhythm despite small external disturbances and quantum errors. But the fundamental problem remained. The time crystal could still only be detected inside quantum processors using indirect methods, meaning it couldn't be seen with the naked eye, until this past September. A group of researchers at the University of Colorado decided to approach the problem from a completely different angle. Do you know what they did? To create a time crystal and see it with the naked eye, they used liquid crystals. These crystals are also in the screen of the phone you're watching this video on right now. They're found not just in phones, but also in computer and television screens. They form the basis of LCD technology. Their job is to bend and straighten according to electrical signals to control the light passing through the pixels. So they act as a kind of light valve for each pixel. They direct the light in a controlled way. So the researchers in Colorado used exactly this controllable nature of theirs. They said, since we can control these liquid crystals so precisely with light or electricity, can't we force them into a rhythmic oscillation with light? In the experiment they designed, they placed a very thin layer of liquid crystal between two glass plates, and they put a special dye inside that reacts to light. Every strike of light set those special dye molecules in motion. And those dye molecules, in turn, push the millions of liquid crystal molecules around them, creating a domino effect. And suddenly, out of a controlled chaos, a brand new order was born. Thousands of patterns inside the liquid crystal began to organize themselves. The researchers saw color-changing patterns that lasted for hours, undulating with their own internal rhythm. And at that moment, for the first time, a time crystal became visible to the naked eye. Okay, that's all well and good, but what is this discovery going to be used for? I can almost hear you asking. I'll talk about that. But first, my friends, we need to fully grasp this. This thing we call a time crystal is a brand new state of matter. I'm saying this to explain just how important this discovery is. What do we learn in school? That there are 4 states of matter, right? Gas, liquid, solid, and plasma. But now scientists are saying that there is also a state of matter called a time crystal. This opens a brand new door in physics. So, what's behind this door? In other words, what kind of practical benefits can time crystals provide us? For example, today's quantum computers are incredibly powerful, but they are also just as sensitive. The slightest vibration, the slightest change in temperature, can disrupt those quantum units called qubits. Time crystals, on the other hand, are surprisingly resilient to external factors by their very nature. They maintain their internal rhythms for a very long time. Thanks to these properties, quantum information can be kept more stable. This means more resilient quantum memories can be developed against errors. Of course, we haven't seen this reflected in everyday technology yet, but some steps have been taken at the experimental level. I mentioned the study done with Google's quantum processor in 2021, as you'll recall. In the coming years, there will of course be many more studies like this, and we will likely see the practical benefits of time crystals more clearly. Another possible benefit is related to precise measurements. It's not so easy to detect the deepest secrets of the universe, like dark matter or the gravitational waves that bend spacetime. Because for that, we need incredibly sensitive sensors. Thanks to time crystals, a flawless measurement device with not even the slightest deviation could be produced in the future. Time crystals can also be used for security purposes. Imagine a special time crystal seal being imprinted on a credit card or a passport. This seal won't be like a static image or a hologram. When a light signal is sent to it with a special reader, it can come to life and respond with a unique, pre-programmed rhythm. Thus, counterfeiting could theoretically become impossible. Of course, if these are implemented, they are very important developments for the future. But I think there's something even more important than these. The time crystal can also give us ideas about the nature of time. Physicists who asked if matter could have a pulse have found the answer. Under special conditions, matter can find its own inner rhythm, its own heartbeat. Didn't everything start with a rhythm anyway? Wherever we look in the universe, there's a rhythmic cycle. Night and day, the changing of the seasons, birth and death. Everything is made up of repeating periodic cycles. And the time crystal could be the first physical evidence of this in the lab. A substance with its own cycle, its own rhythm. This brought that famous question to mind. Is time a straight line or a rhythmic cycle? Perhaps we can hear the answer every moment, every second, in the rhythm of our hearts.